Mechanics M1 May 2012, question 5. Variable acceleration question. In part 1 we're asked to find the velocity, and that's the integral of acceleration with respect to time. So if I integrate 2t minus 10 with respect to t, I get t squared minus 10t plus c. I have to read the question to get my boundary conditions, and when t equals 0, v is 21, which means that c must be 21. So the velocity is t squared minus 10t plus 21. To find the times when the particle is at 0, we put velocity equal to 0. So t squared minus 10t plus 21 equals 0. For quadratic to solve, I'm going to factorise. You can use the quadratic formula. T minus 7 upon t minus 3 equals 0. So t equals 7 or t equals 3. Part 3, find an expression. Part 3, find an expression for the displacement, and displacement is the integral of velocity. So we're integrating t squared minus 10t plus 21 with respect to t. Gives us t cubed over 3 minus 5t squared plus 21t plus c. Read the boundary conditions in the question. When t is 0, s is 0, and that implies that c is 0. So s is t cubed over 3 minus 5t squared plus 21t. In any total distance question, there are 3 things you're interested in. Where is the particle at the start? When t equals 2, the particle is 24 2/3 from the origin. Where's the particle at the end? T equals 6. It's 18 metres from the origin. And where's the particle when v equals 0? In this case we have 2 times, 3 and 7, but we're only going to use 3 because 7 is outside our range, and it is 27 metres from the origin. So if I draw a line to represent my origin, at the start my particle is 24 2/3 metres from the origin. When v equals 0, it is 27 metres from the origin, and when t equals 6, it is 18 metres from the origin. So in the first leg of motion, the particle has travelled 27 minus 24 2/3, 2 1/3 metres. And in the second part of the motion, it has travelled from 27 metres to 18, so it has travelled a total of 9 metres. And if I add the 2 parts together, it has travelled 9 plus 2 1/3, 11 1/3 metre.